Good afternoon, students.
Good afternoon, ma'am.
Okay. So, the last classes we were discussing about the resistance and the factors affecting the resistance. There are 4 factors are there. They are length, nature of the material, temperature and the area of cross section. So, these are the factors that affecting the value of resistance. So, here I have a question to you. What do you think? Will the current is flows more easily through a thicker wire or through a thinner wire? What do you think? Will the current is flows more easily through a thinner wire or thicker wire? Try to guess.
Thinner.
Is it is flows through thinner wire? Why? Is it is because of
Less
thin in shape? What do you think? What about others' opinion? Here Rizwan say his opinion. Anyway, it's right. Okay, Rizwan, I appreciate your initiative. So my next question is this. Will the current is flows easily through a thinner wire or thicker wire? Anyway, Rizwan present his theory or idea. That is, it is flows more easily through a thinner wire. What about others?
Thinner.
Is it is flows through thinner wire. Okay. Is there any other different opinion? All of them are going with this one. The current is easily flow through a thinner wire. But actually the answer is thicker wire. The current is flows more easily through a thicker wire. Why? Can you guess the reason? For a thicker wire, what about the area? Area of cross section of a thicker wire is it is less? Thicker wire, thicker, it is more. Okay, for a thicker wire the area of cross section is more. So whenever the area increases, what happens to the value of resistance?
Decreases.
Resistance decreases. So resistance decreases, what happens to the value of current?
Increases.
Current increases. So from this we can say that the current is more easily flow through a thicker wire than that of a thinner wire. Most of the students have a tendency to write it is through thinner wire the current is flows more easily, but it is a wrong concept because thinner wire have less area. Okay, whenever the area increases, resistance is also decreases. Okay, here the area is less. In the case of a thinner wire, area is less. That is, area decreases, resistance increases. So what is resistance? Resistance is the property to oppose the flow of current. So whenever the resistance increases, the current is not flowing through the circuit. But in the case of a thicker wire, it possesses more area. So here the area of cross section increases, automatically the resistance decreases. So the current is easily flow through a thicker wire. So if you have a question like this, will the current is flows more easily through a thinner wire or thicker wire? The answer is thicker wire, because for a thicker wire the area of cross section is more, so the resistance will be less, so more current will flow through the thicker wire. Is it clear?
Yes, ma'am.
Okay. So today we are going to discuss the next topic, that is resistance of a system of resistors. So in our previous classes we are detailed explained about our resistance. Resistance is the property, or it is the ability to oppose the flow of current. That is what is known as resistance. And what is the SI unit of resistance? Ohm. Ohm is the SI unit of resistance. And then we discuss about the various factors that is affecting the value of resistance. So now we are going to discuss about the combination of resistors. Students, we know that in our daily life we are dealing with a different or wide varieties of electric gadgets. Different and wide varieties of electric gadgets are used. So depending upon the electric gadget, the number of resistors are also different. Okay, depending upon the electric gadgets, the number of resistors used in them are also different. So today we are going to study how we can arrange these resistors inside the electrical gadgets. how these different types of or different number of resistors, sometimes depending upon, for example, in the case of a television, if you are observing the circuit board of television, there is a lot of resistors are there. So sometimes it is nearly 15 to 20 number of resistors are there. So there are some different types of mechanisms are there to arrange these resistors. Okay, so that is what is we are going to discuss here today. That is about the resistance of a system of resistors. So all of you write the next heading, resistance of a system of resistors. Resistance of a system of resistors. Commonly we have two system of resistors are there, or there are two methods to connect the resistors. The first one is resistors in series. Resistors in series. And the second one is resistors in parallel. Resistors in series and resistors in parallel. There are two system of resistors. The first one resistors in series and the second one resistors in parallel. We are going to discuss the two system of resistors one by one. Resistors in series and resistors in parallel. So first of all we can discuss about resistors in series. Resistors in series or series combination of resistors, or in simpler words we can write resistors in series. Okay. Suppose you imagine if we have three number of resistors are there. Do you remember how we are representing the resistors? What about the conventional symbol for resistors? Any idea? Conventional symbol. This is the symbol used to represent the resistors. Okay. So suppose here we have three resistors are there with resistance R1, R2 and R3. Okay. One more resistor is needed here. Okay. R3. All of you listen here first. So here we have three resistors. They are represented as R1, R2 and R3. If the end of the resistor R1 is joined to the end of the resistor R2, then the end of the resistor R2 joined to where? Here the end of the R3. Okay. So here one end of the R1 is joined to R2. Similarly, the other end of the R2 is joined to R3. That is the end-to-end connection of resistors. Here we have different resistors are there with resistance value R1, R2 and R3. Then the end-to-end connection of resistors are called series combination of resistors, or we can say it is the resistors in series. So what is resistors in series? End-to-end connection of resistors. End-to-end connection of resistors are called series combination of resistors. End-to-end connection of resistors are called series combination of resistors. You just imagine if you are holding the hands of your friends and if you are standing in a row. So that is what is meant by resistors in series. You only need to write the first sentence. When two or more resistors are connected end to end, they are said to be in series. So this is the definition for series combination of resistors. When two or more resistors are connected end to end, then they are said to be in series. This is the definition for the series combination of resistance. You don't need to copy down the other sentences, only write the first sentence. That is the definition for series combination of resistance. When two or more resistors are connected end to end, they are said to be in series, or end to end connection of resistors are called series combination of resistors. Is it clear? Is it clear, students? So here we are define the series combination of resistors. If we have two or more resistors are present in an electrical gadgets, and if they are arranged end to end, then we can call it as series combination of resistors. The end to end connection of resistors are known as series combination of resistors. Okay. So now let us see a circuit with a series combination. For that, here we want some apparatus. How many resistors that we are going to consider here? 3 resistors are needed. Okay. Okay. One more resistor is needed. Okay. Then what is the other components? We need to measure the voltage. So which component is needed to measure the voltage here?
Voltmeter.
Yes, it is the voltmeter. Here we need the voltmeter. To measure the current, I need one more device. What's that?
Ammeter.
Ammeter. Okay, here I want an ammeter. And to the cells are also needed. Okay, so here we have the voltmeter and ammeter, and we need some more items to construct the circuit, that is cells, battery. Okay, that's all. So now we can arrange them. All of you take the figure 12.6 of your textbook. Figure 12.6. Page number 210. Figure 12.6. We are going to arrange these items here. Okay. So here we have 3 resistors are there, and here we are going to construct a series combination of resistors. So here we have R1 and R2. The next one is R3. Okay. Then how the voltmeter is connected to a circuit? How the voltmeter is connected to a circuit?
Parallel.
It is connected parallel. Okay, so here we can arrange the voltmeter here. Now here we want the cell. This is our ammeter, and we place the cell. Okay, and one key is needed. We can draw the key. Okay. So this is the arrangement that we are going to do here. So what do you mean by series combination of resistors? Series combination of resistors. Can you define what do you mean by series combination of resistors? Rose, what do you mean by series combination of resistors? The definition. Resistors in series. Yes, the end-to-end connection of resistors. So here we have 3 resistors are there with resistance value R1, R2 and R3. Since they are connected in series, we need to connect them end-to-end. The end of the R1 is connected to end of R2. The next end of R2 is connected to R3. Okay. Then the end of R3 is connected to where? From the figure, can you identify? From the end of R3 is connected to where? Figure 12.6 of your textbook. 12.6, page number 210. The end of the R3 is connected to where? Yes, it is connected to the voltmeter. It is connected to voltmeter here. Okay. The other end of the R1 is connected to where? Voltmeter, the another terminal of the voltmeter. And one more wire is go and it is connected to one end of the ammeter. Another end of the ammeter is connected to the end of the cell or the battery, and the next end is connected to a key. Now the key is closed, and then the other end is connected to the R3. Okay, and the current is flowing from positive to negative terminal. So this is the circuit construction with the help of 3 resistors in series. This is the series combination of resistors. Okay, so the end-to-end connection of resistors are called series combination of resistors. Then the effective resistance, the total resistance, here we say that here we consider 3 resistors are there. What are the resistance value of these 3 resistors? What are the resistance value of these 3 resistors? If it is not clear, why are you remaining silent? What are the resistance value of these 3 resistors?
R1, R2.
Yes, R1, R2 and R3. Why you are hesitant? You can unmute and say. If it is right or wrong, no problem, you can say. So here we are take the 3 resistors with resistance value R1, R2 and R3. And in a series combination, the first point, the total resistance can be calculated by, in a series combination, the total resistance is also known as effective resistance. The total resistance or effective resistance is given by, the total resistance or the effective resistance can be calculated by, this is an equation you must study. In a series combination, the total resistance or effective resistance is given by R is equal to, capital R is equal to the sum of the resistance of individual resistors. So here we have 3 resistors are there with resistance value R1, R2 and R3. So what is the total resistance? R is equal to sum of the resistance of individual resistance, that is R equal to R1 plus R2 plus R3. Is it clear?
Yes, ma'am.
Okay. So this is the equation for calculating the total resistance of a circuit. First of all, you just study the equation for calculating the total resistance. It will be helpful whenever we are doing a problem. So after the discussions, we can do a problem, then it will be more clear to you. Okay. The total resistance or the effective resistance is given by R is equal to R1 plus R2 plus R3. This is for series combination. So here we have a circuit with 3 resistors R1, R2 and R3. The 3 resistors with resistance value R1, R2 and R3. Then the total resistance, it is also known as the effective resistance. The total resistance or the effective resistance of the circuit can be calculated using the equation R is equal to R1 plus R2 plus R3. Or here you can use the subscript S. This RS stands for the total resistance of series circuit. The total resistance of series circuit is given by R1 plus R2 plus R3. Is it clear?
Yes, ma'am.
Bhadra, what is the equation for calculating the total resistance of a series combination? Bhadra.
R is equal to R1 plus R2 plus R3.
Okay, R is equal to R1 plus R2 plus R3. Try to by heart this equation. Now we are moving to the second point regarding with the series combination of resistors. So the second point, in a series combination, the current flowing through the circuit is same. In a series combination means series combination of resistors. So in a series combination, This is very important portion of this chapter. Very, very important portion. In a series combination, the current flowing through a circuit is same. The current flowing through the circuit is same. In a series combination, the current flowing through a circuit is same. This is the second point regarding with that of the series combination of resistors. The first one is the total resistance. Here we are consider 3 resistors with resistance value R1, R2 and R3. Then the total resistance can be calculated by the equation Rs is equal to R1 plus R2 plus R3. Now the second point regarding with that of the series combination of resistors. In a series combination, the current flowing through the circuit is same. Okay. Because in this figure you can see the R1, R2 and R3. The series combination mean end-to-end connection of resistors. So whenever the circuit is closed, the current is started to flow through this ammeter and then the current is reaches to the resistor R1. The same current I is passing through R1, the same current I is passing through R2 and the same current I is passing through R3. So this is our second point. In a series combination, the same current I is passing through the resistors R1, R2 and R3. Is it clear?
Yes, ma'am.
Okay. Now we can discuss the third point regarding with the series combination of resistance. According to our third point, the potential difference across the series combination of resistors are different, or we can say the voltage or the potential difference, or potential difference through each resistors. The voltage or potential difference through each resistors are different. Through each resistors are different. Okay, the voltage or potential difference through each resistors are different. This is the third point regarding with that of the series combination of resistance. The voltage or the potential difference through each resistors are different. So once again we can go to our image. That is, here we have a cell, the cell with the 12 voltage. This 12 voltage is supplied to the circuit, but the voltage or the potential difference corresponding to R1 is V1 and that of the R2 is, can you guess the potential difference through R2? V2, good. Then the potential difference through the resistor R3 is V3, very good. Okay, so in a series combination of resistors, the potential difference through each resistors are different. The potential difference or the voltage through each resistors are different. The voltage or potential difference through each resistors are different. That is, you can differentiate each potential difference. V1 is the voltage through what resistor? V1 is the voltage through R1. Good. Similarly, V2 is the voltage through which resistor? Unmute and say. R2. And V3 is the voltage through, yes, R3. So here we have 3 resistors, then the total resistance is given by R is equal to R1 plus R2 plus R3. the three resistors are connected in series. That is, the end-to-end connection of resistors are called series combination of resistors. In a series combination, the current flowing through the circuit is same. The same current I is passing through all the resistors R1, R2 and R3. Then by the third point, even though the current flowing through the circuit is same, the voltage difference through each resistors are different. That is, the voltage through the resistor R1 is V1, the voltage through the resistor R2 is V2, and the voltage through the resistor R3 is V3. Is it clear? Any doubt up to here? So my next question, then how we can calculate the total voltage? Then the total voltage V is equal to, any guess the equation for calculating the total voltage? Then the total voltage V is equal, yes, exactly, V is equal to V1 plus V2 plus V3. Then the total voltage of the series combination is given by V is equal to V1 plus V2 plus V3. Okay.
Yes, ma'am.
Then by Ohm's law, we have an equation for calculating potential difference. What is that? By Ohm's law we have, what is the equation for Ohm's law?
V equal to IR.
Yes, very good. V is equal to IR. By Ohm's law we have V is equal to IR. So students, here we are going to calculate the value for V1, V2 and V3 separately. So by Ohm's law we have V is equal to IR. Put as equation number 1. Give this as an equation number 1. So can you form an equation for V1? If V is equal to IR, what about the potential difference V1 through the resistor R1?
V1 equal to I into R.
I into R1. Very good. V1 is equal to I into R1. Normally all the students have a tendency to write V1 equal to I1 R1. Is it right? Is it right or wrong?
Wrong.
Wrong. Because here the common current I is passing through all the resistors. It is not differentiated into I1, I2 and I3. The common current I is passing through all the resistors. So here the V1, the voltage or the potential difference through the resistor R1 is V1. So V1 is equal to IR1. We can give this equation number 2. Then similarly, what is V2? Now you get an idea how to calculate the V2. If V1 equal to IR1, then the potential difference through, yes, I into R2. The potential difference through the second resistor, that is R2, is V2 is equal to the current through the resistor into the corresponding resistance value, that is R2. So V2 is equal to IR2. This is our equation number 3. Here we have one more voltage is there, that is the voltage across the resistor R3. So V3 is equal to V1 equal to IR1, V2 equal to IR2, V3 is equal to I into R3, IR3. This is our equation number 4. Okay. So now we are going to substitute these 2, 3 and 4 into, we can give this equation as equation number A. The total voltage V is equal to V1 plus V2 plus V3. Give that equation number A. Now we are going to substitute all these equations, equation 1, 2, 3 and 4 to the equation number A. What is our equation number A? Equation number A is V is equal to V1 plus V2 plus V3, right? Then what is V? Here from equation number 1, we have value for V. What is V? Nirubama. By equation number 1, what is the value of V? IR. So we can substitute that value here. So instead of V, here we can write IR. This is according to Ohm's law. We know that V is equal to IR. Similarly, what is V1? Vishnupriya, what is V1? V1 is equal to IR1. We can substitute that value here. So it becomes IR1 plus what is V2? Adidev, V2?
Yes, ma'am. IR2.
IR2, good. Plus Savio, what is V3?
IR3.
IR3, good. Okay, so here V is equal to V1 plus V2 plus V3 becomes IR is equal to IR1 plus IR2 plus IR3. Or we can write IR is equal to, what is common all these equations? What is common here? Nisia, which term is common here in this equation? I is common, so we can take it as outside. Okay, here IR1, in the second term IR2, the third term IR3. So in all these terms, I is common, so we can take it outside. Then what is left? I into
R1, R2 and R3.
yes, R1 plus R2 plus R3. IR is equal to I into R1 plus R2 plus R3. Now we can cancel the I from both sides.
Yes, ma'am.
Okay, then what is left?
R,
R equal to
R1 plus R2.
R1 plus R2 plus R3. Hence it is proved. This is the equation for calculating the total resistance of the series combination of resistors. R is equal to R1 plus R2 plus R3. This is the equation for calculating the total resistance or the effective resistance of a series combination of resistors. Is it clear? Is it clear or not?
Yes, ma'am.
Okay, so in order to derive this expression, we are starting from the voltage. The total voltage can be calculated in a series combination of resistors. We know that the potential difference or the voltage through different resistors are different. So the total voltage can be calculated by the equation V is equal to V1 plus V2 plus V3. Then we use the Ohm's law here. According to Ohm's law, we know that the potential difference V is equal to IR. So in the similar way, we are calculating the potential difference through the resistor R1, that is given by V1 is equal to IR1. Similarly, the potential difference through resistor R2, it is given by V2 is equal to IR2. And the potential difference through the resistor R3, it is given by V3 is equal to IR3. So here we get 4 different equations. Okay, 4 different equations. Then we substitute all these 4 equations into the main equation for calculating the total voltage of a series combination of resistance. That is V is equal to V1 plus V2 plus V3. Then we get IR is equal to IR1 plus IR2 plus IR3. Then in the next step, we take the common term outside. That is the current term. The term current is common. So we taken it as outside. So it becomes IR is equal to I into R1 plus R2 plus R3. We cut the term I from both sides. So we get RS is equal to R1 plus R2 plus R3. I hope this derivation is clear to you, right? Okay. So once again we can recall the terms associated with the series combination of resistance. After that we can move to a problem. Then it will be more clear where we are applying these equations for calculating the resistance and voltage. Okay. So the first question is to Rifa. Rifa, can you define what you mean by series combination of resistors?
That conductor depends on the and potential difference within.
Okay. What do you mean by series combination of resistors? Define the series combination.
That we use various resistors in different combinations.
Yes, and how they are connected in a series combination? How these various resistors are connected?
like R1, R2, and R3.
Okay, R1, R2, R3, these are the three different resistors. How they are connected in electric? Yes? I want that particular word. What's that? Yes?
They are connected in a series.
They are connected in?
Series.
Yes, they are connected in series. What is the exact definition for the series combination of resistors? Vishnupriya.
The current is in the same in every part of the
Students, I request all of you to please switch on your videos. Please switch on your videos. Okay. Then Vishnupriya, what do you mean by the series combination of resistors? Yes, exactly. The end-to-end connection of resistors are called series combination of resistors. Okay. The end-to-end connection of resistors are known as series combination of resistors. So the next question to who is here? Anne-Marie.
Yes, ma'am.
What is the equation for calculating the total resistance?
R1 plus R2 plus R3.
R is equal to R1 plus R2 plus R3. And what is the other characteristics of series combination? Fia? Another characteristics of series combination?
The current is flowing through the same.
The current that is flowing through the circuit is same. The same current is flowing through all the circuit. Okay, good. Then the next questions to Aditya Krishna. Are you joining now?
No, ma'am.
Okay. Then what about the another characteristics of the series combination of resistors? The current flowing. Okay. Continue.
The series.
Yes. All of you, please switch on your videos. Please switch on your videos. Yes, Aditya. What is the other characteristics of a series combination of resistors? Riswan. I think Riswan is ready to say the answer. Yes. Actually, the Nirubaba get frustrated and he sent the answer in chat box. The voltage is different. The voltage or the potential difference is different in a series combination. And hence, Steve, how we can calculate the total voltage in a series combination of resistors?
Will you say the definition for the parallel one more time?
Not parallel, dear. Series. Here we are only discussing about the series combination of resistors. The series, the end-to-end connection of resistors are called a series combination of resistors. Okay, end-to-end. If you just imagine, if the two friends are standing nearby, if you are holding the hand of another friend, similarly your friend is holding the hands of your other friend, then you becomes in the form of a series combination. Okay, that is what is meant by the series combination, end-to-end connection of resistors. Hence, Steve, how we can calculate the total voltage or the total potential difference in a series combination?
IR.
That is Ohm's law. If there are different voltages are there, V1, V2, V3, then how we can calculate the total voltage of the circuit?
I equal to V by
No, V equal to the total voltage. Who is ready to say the answer? Anyone, unmute and say.
V is equal to V1 plus V2 plus
Yes,
V3.
very good. V is equal to V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. And Adil, what is the equation for calculating V1?
V1 is equal to IR1.
V1 equal to IR1. Prajot, V2.
V1 V2 equal to IR2.
Good. Aman Shakir, V3. V1 equal to IR1, V2 equal to IR2, V3 then the same question.
IR3.
IR3. V3 is equal to IR3. So I hope that this series combination of resistors is clear to you, right? Okay children, so now we are moving to the some problems regarding with it. Series combination of resistors. So this is the resistors in series. When the three resistors, it is not only needed to connect the resistors R1, R2, R3, you can take any number of resistors. If it is 4 resistors are there, then the equation become R1 plus R2 plus R3 plus R4. If there are 5 resistors, then the effective resistance become R1 plus R2 plus R3 plus R4 plus R5. Similarly, if there are n number of resistors are there, plus etc. up to n, Rn. Okay, so this is the equation for calculating the total resistance in a series combination. So when 3 resistors R1, R2 and R3 are connected in series, then the current in all the resistors is the same. The second one, the total voltage across the resistors is equal to the sum of the voltage across each resistors. That is, the potential difference is different. Current is same, but the voltage is different in a series combination, and the total voltage is given by V is equal to V1 plus V2 plus V3. Then the last point, the equivalent resistance is the sum of the resistance of each resistors. That is, in a series combination, the total resistance is given by R1 plus R2 plus R3. So this is the derivative step that we are already discussed here. Now here you have a problem. So write the question. Calculate the equivalent resistance for the circuit which is connected to 24 volt battery, and also find the potential difference across 4 ohm and 6 ohm resistors in the circuit. Try to copy down the question and then try to find the answer by yourself. Calculate the equivalent resistance for the circuit which is connected to 24 volt battery, and also find the potential difference across 4 ohm and 6 ohm resistors in the circuit. Try to copy down the questions for today. We can discuss the answer in the next class because it's the time. So you can expect the long answer questions from this session. Okay. So some series and parallel combination circuits are given. You are asked to find out the total resistance and the voltage through each resistor. Here we want to calculate the voltage through R1, that is through 4 ohm resistance, and the voltage through R2, that is through 6 ohm resistor. So here we have the equation for calculating V1 and V2. Use that equation and try to find out the V1 and V2.
Ma'am, I can't hear.
Yes? Is it over?